So the area of window X, the general equation equals the area of the circle divided by 2, because we only need half of the circle, plus the area of the rectangle, which we'll call R. So we could create a small legend up here where AC equals area of circle, and AR equals the area of the rectangle. I could do something like that. So related to our estimate, we need to generally come up with what the area of the circle might be. So to find area of the circle, so AX, area of a circle would be pi times the radius of that circle squared. Then we would have to divide that by 2. And what would the equation of area of the rectangle be? Well, it would be the length of rectangle X times the width of rectangle X. I'm just going to put a dot to represent multiply. I don't want to confuse the multiplication symbol with the lowercase x for window X. So let's try and finish this estimate. So AX equals, well, pi is about 3. So if it's approximately 3, we're going to be multiplying 3 times the radius. And if we go back to the image, diameter is 122. That means that we have to break 122 in 2. So to find the radius, we have to divide the diameter by 2. So the radius would be 122 centimeters divided in half. 122 is about 120, which is approximately 60, because 2 60s equals 120. So what we could say is that we're going to be doing, for area of the circle, 3 times 60 squared divided by 2. Again, these are just estimated values. And so this makes it easier, because if we're going to multiply 60 by itself, well, 6 times 6 is 36, and then we just add the 2 zeros, because we're multiplying 60 by 60. So 36 with 2 zeros. So we would have 3, and that's about, so if it's 3,600, we could say it's about 3,500, or we could say we could round it up to 4,000. It would be up to you. But the closer round would be to 3,500, and that's rounding down. And then I would have to divide that by 2. And now what I can look at is just this section. If I have 3 35s, well, 2 35s would give me 70. So 3 35s would be a little bit more than 100. Okay, and the 100 would look like this. So we're looking at 10,000, or 3 3,000s, which would be 9,000, and then we'd have to divide that by 2. So our approximate answer, again, this is for area of the circle portion only, would be about 5,000. And that would be centimeters squared. So that's just for the circle. Now, if we were to take the same equation and add the area of the rectangular portion, well, it would just simply be length times width, which was about 100 times 100. And 100 times 100, so it's approximately 100 centimeters times 100 centimeters, which is, in this case, the pattern for multiplying numbers that end in 0, just add the number of zeros. So it would be 1 with 4 zeros. And that would be centimeters squared. So we could add those together. I'm just going to fill in the same number here until we get to the very end when we can add them together. Excuse me. Okay, so the area of window X is approximately equal to, approximately equal to 10,000 plus 5,000, which is about 15,000 centimeters squared. Approximately. So that's just window X. So window Y, we would follow the same steps to run our estimate. Notice it's not even a calculation because we didn't use the real form of pi that we should be using, which would be rounded to the nearest hundredth, which would be 3.14. And we didn't use the real amounts of the length or the width, which are 122 and 84 centimeters respectively. We rounded those values to 100 and 100 to make it a little bit easier for the calculation. So this is just the estimate. So we believe that our low estimate, so that's low, our actual answer is going to be slightly more than 15,000 when we run the real calculation for window X. So window Y, it's 115 by 88. So for window Y, we would run the exact same calculation where area of equals the area of the circle plus the area of the rectangle, and then we have to substitute which portion or what the parts are to find the area of the circle. So we would need pi times the radius squared, but that would be the radius for shape Y. I have to divide that by 2. That would be the length of Y times the width of Y for the rectangular portion. And that equals approximately 3, and the radius for Y, we would have to find it. So it would be 115 divided by 2, because the radius is half of the diameter. And the diameter for the window Y is 115. So that's about 120 again, and approximately half of 120 is what? Or we could say it's 110. Half of 110 is what? It's about 55, so why not make it easier and just call it 50? So half of 100 would be 50. So again, we're rounding down. So if we say that's 50 centimeters squared, divide all that by 2. In the meantime, we might as well do our rounding for length and the width of the rectangle. So we could say that the length is approximately 100 centimeters, and the width is approximately, we could say 100 too, but why not try 80 this time? Because it's 88, it's close to 80. It's actually closer to 90, but let's round down. So our answer is going to be an underestimate. Underestimate. So area Y is approximately equal to, well, 50 times itself would be 25 plus 2 zeros. So we'd have 3 times 25, 2 zeros. Centimeters squared divided by 2. And we'll leave the rectangle the same until we want to get to that. So let's finish up what we're doing with the area of the circle, just as an estimate. So we have 2,500, and we have 3 of them. So 3 25s is 75. So 3 times 2,500 should be 7,500 centimeters squared divided by 2 plus 100 centimeters times 80 centimeters. We're going to do one step at a time just so we don't lose track of what we're doing. And half of 750. Well, if that's about 8,000, what's half of 8,000? About approximately 4,000 centimeters squared plus 100 centimeters times 80 centimeters. But let's do the next part here. We'll leave the 4,000 as it is, and we'll do the area, which is 8 times 1, which is 8, and then add the zeros. So 8,000 centimeters squared. That means the approximate area of window Y is about 12,000 centimeters squared. Now comparatively, in our estimates, both are underestimates, but we believe that according to this, window Y is actually smaller. Right away, just by comparing them and looking at them, smaller than X. But remember, they're both underestimates. This is an underestimate, and this one is also an underestimate. Okay? So the next step would be to take our estimates and then actually calculate the question, or calculate the answers to. Okay, so just to recap, we've already done estimates for window X and for window Y, and our estimates state that window Y appears to be a little bit smaller than window X. They're both underestimates. The next step would be to have a look at the actual calculations. So window X, the estimate was about 15,000 centimeters squared, and that was low. Here are window X calculations. Now a couple things I need you to understand here. We've done exactly the same thing with the general equation that we did in the estimate, where we took area of window X, and it equals the area of the semicircle, which is pi r squared divided by 2, plus the area of the rectangular part of the window, which is length times width for window X. And all of the calculations, the real calculations, are done in sequence in the Think Aloud section here. The only calculation that's not done there is finding the radius. That's right here. But that's okay. And it might be a good idea to actually label what the calculations represent. But my technique, the way I did it, was to try and stay as organized as possible. So the first calculation I had to do, according to Bedmas, which is brackets, exponents, division, multiplication, whichever comes first, and then addition, subtraction, whichever comes first, I had to do the exponent first, which is 61 to the exponent 2. And you'll see that calculation here. So I ran my calculation first, and then I did the opposite operation by taking my final answer and dividing it by 61. I double checked that I get the same number that I started with, which was 61, and then I put a check mark and said match, because that means when I did my opposite operation I got the same value that I started with in the original calculation, so my answer must be right. Then I put that number in here in the equation. The next step would be to do the multiplication. Multiplication being, let's see, .14 times, or multiplied by 3,721. So I'm actually still trying to find the area of the circular portion, or the semicircular portion. And that should be 11,683.94. And you'll notice here that I've done the multiplication. So right now I'm actually reviewing all of my calculations, which is part of step 5, where I go through the calculations and then I'm going to do a cross-check to make sure things make sense. Again, looking at the general equation, I'm supposed to divide my area of the circle by 2. I'm looking back at my calculations and I think I missed a step. So it's very, very important to go through the calculations and make sure you didn't miss anything. But I matched, all the calculations make sense. Then I did the rectangular calculation, which was length times width, 122 times 84. I got an answer, took my answer, divided it by one of the given numbers, 122, and I actually ended up with 84, which was the other given number in the question. That means it's correct. My double check matches my actual. Then I jumped right to my addition. So just by looking at this, I've identified and found an error. There's one small mistake here. And the small mistake is that I did not divide by 2, or did I? Can you see whether or not the division by 2 has been completed for the area of the semicircle? see, if you look at the calculations here, I did r squared, which is here. I multiplied the answer of r squared by pi. But where did I take this value and divide it by 2? Can you see it anywhere? In fact, when I added it later, I added the original. I didn't divide it by 2 ever. So maybe I'm supposed to be dividing that by 2, I think. What do you think? Would it be okay to divide the final answer written here by 2? Does it matter if I don't follow my pattern or my plan exactly as I was supposed to? Would that give me a different answer? Meaning, if I divide this by 2 and then continue through, would it be the same answer as if I divided my final answer by 2? Something to think about. There's always more than one way to plan a solution. Regardless, if I have to divide this by 2, I'm going to end up with an answer. So 21,931.94 divided by 2 I believe the answer is going to be a little bit low. What do you think? So if we were just to stop there, that's 10,965. According to our estimate for x, 15,000 centimeters squared is a low estimate. Did we round everything down when we did our estimate? Look carefully at this. So did we round down our radius here? Half of 122 is more than 60, so 60 is rounded down. We rounded down pi because 3.14 is bigger than 3. Did we round down our length and our width? No. We rounded one down and we rounded one up a lot, from 84 to 100. So that this is not necessarily going to be low. We've overextended a generalization of our estimate. It may not be low. It's possible that it's not. Okay? Or it could be around the same. But perhaps our estimate is even lower, or it could be a little bit high. We don't know. We don't know the impact that this 84 rounded to 100 in the area of the rectangular face, what impact that's going to have. Regardless, in our calculation, if we think that the area of x, AX, is approximately 10,965, you'd have to finish this long division to really get the exact number, and then you'd have to multiply your answer by 2 to prove that you get 21,931.94, which is what you started with. When you're done, this answer is so close to the actual estimate of 15,000 that you're probably right. As long as all of your double checks and your calculations make sense, you should be fine. So once you're done this, then you have to find the actual for the area of window Y. So now here is the solution for solving the area of window Y. And you'll see all the parts clearly, and that I've double checked and made sure that the calculations and the double checks matched. This one was completed a little bit differently because I've learned from the error that was made in the last one. I actually did the division by 2 after I multiplied 3.14 by the radius squared. So up here in the top left, you're going to see the radius squared. That's the calculation. Here's the double check, and I proved that I ended up with the number I started with. Then I took my radius squared and I multiplied it by 3.14. Got an answer, double checked it, got one of the values I started with, so that matched. After that, I took my pi times the radius and I divided it by 2. And I did that up here. And I ran the double check by multiplying the answer by 2, and I ended up with the value I started with, 10,381.6250 centimeters squared. and I put that in as the summary of the area of the semicircle. And then down here I multiplied the length times the width to find the area of the rectangular portion, double checked it and ended up with the length, which is what I was looking for, one of the values I started with. Then I added the area of the semicircle plus the area of the rectangular portion, and I got the area of the window. Double check the area of the window, subtract the area of the rectangular portion, and I got the area of the semicircle. That means, with confidence, the area of window Y is 15,310.8125 centimeters squared. Now I can take that value, 15,310, and check my estimate for window Y, which was here, about 12,000. Now that was estimated as being smaller, which is accurate because all the numbers I rounded down. And 12,000 is definitely smaller than the area I found for window Y. A little bit smaller, not too much, because I didn't over round down. Like I rounded down a little bit, but not too much. So this value is accurate for window Y. This value is accurate for window X, based on all of my calculations. Which window, so we have to look at the question itself. It says which window has a larger viewing area, and how much greater is this area? So now what we have to do is compare the two areas. Area window X is 10,965, area window Y is 15,000. So we can quickly estimate that area of window Y is about 5,000 centimeters squared larger, but then we would have to do the actual calculation too. It says round your solution to the nearest whole number. So as you can see, we've got all of our information, and all the calculations go all the way to the nearest 10,000th. But now we need to round them to the nearest whole. So let's go back to the area of window X. So looking at the area of window X, to round this amount to the nearest whole, we simply look at the digit in the tens column, which is a 9, and because it's greater, or it's 5 or greater, that means we round the digit in the ones column up by 1. So area of window X rounded to the nearest whole is equal to, now because we're rounding I'm going to say it's approximately equal to 10,966 centimeters squared. Now the area of window Y, again look at the digit in the tens column, it's greater than 5 or more, so that means we have to round the digit in the ones column up by 1. So area of window Y is approximately equal to, because we're rounding, 15,311 centimeters squared. So now we've got the two values. The final step is to actually determine which one, show which one is bigger and by how much. So let's take area Y, which is 15,311. Area Y, 15,311 centimeters squared. And area X, which is 10,966 centimeters squared, and we're going to subtract the smaller from the bigger, and that will give us the difference between the area of both windows. So to summarize, we go back to window X and look at the estimate. We made an estimate, and we've identified that this estimate might be high, it might be low, it's hard to say, because in this case we've rounded some values up. Like we said that the width originally is 84, but we rounded that to 100 in the estimated calculation, and our length was 122, we rounded that down. So our estimate could be close to the actual. We don't know if it's high or low, so we can't conclusively state that it's lower than the actual. And we went on to complete the estimate of Y. And the estimate of Y, we rounded all the values down, because for Y, the length was 115, and we rounded that to 100. The width was 88, we rounded that to 80. 3.14 we rounded down to 3. And then we did the same thing with the radius, that should be 57, we rounded it down to 50. So we knew that this would be smaller than the actual value of the window for Y, and I think here it says smaller than X, but we can't conclude that yet. But we know for sure that this area is going to be smaller than the actual. We can say that with confidence because we rounded everything down as an underestimate. Then we went on to actually do the calculations for area X and concluded that it's 10,965.97 centimeters squared. And in the question it says round your answers to the nearest whole. So when you're finished all of the calculations, then you do the rounding. Never do it early. Because if you round too early, every time you round, you change the quality of the answer, making it less precise. So if it tells you to round, wait until you're done, wait until you're at the end, and then do your rounding. So area X, in this case, is 10,966 centimeters squared. Every calculation was double-checked. You'd have to do the same thing to guarantee that you're accurate. Otherwise, there's always a level of uncertainty in your work. Here are the calculations for area Y. Again, same thing, same rounding. In this case, the rounding, as we talked about already, 15,310.8125. The digit in the tenths column is 5 or greater, so the digit in the ones column rounds up by 1. So it becomes area Y equals 15,000, approximately 15,311. We say approximately because it's a rounded value. And now we run our comparative analysis between area Y and area X, realize that the area of window Y is about 4,000 centimeters squared bigger. In the Think Aloud, I've written my overview and my comparative analysis. So this would be step 5, where I describe the estimate for window X and compare it back to my actual, talking about whether or not it's an estimate or an overestimate or an underestimate. I conclude the accuracy of my estimate and the accuracy of my actual. Are they close to one another? If they're close, then I can use the estimate to help me prove that my actual makes sense. I should also make comments about my double checks. Were they all accurate? Did every single double check match the actual, the given values? If it didn't, I'd have to go back and check, and if it didn't, I can't be confident in my work. I do the same thing with explanations for the calculations for area Y, explaining that the estimate is close to the actual, and then I can develop a conclusion that I can say with confidence after I've explained and compared the values. And notice, I'm not just saying it generally. I'm not just saying, oh, my estimate was close to my actual. I'm clearly identifying what my estimate was. I'm clearly identifying how far away they were. I'm giving specific amounts as I analyze the data I've collected. Make sure you give specific amounts when you're running your comparative analysis. And at the very end, again, I know the exact amount, everybody can see it highlighted, but it's okay at this point to say I conclude with confidence that window Y has a larger viewing area than window X by approximately 4,000 centimeters squared. That's close enough, and if someone really wants to see it, they can see it highlighted in huge letters, or huge numbers, that it's 4,345 centimeters squared. So the next step would be step 6, to look at someone else's solution and see if they've done operations in a different way or techniques in a different way. Try and find a new way to solve part of a problem or all of the problem, and then test your ability to use the new technique learned from someone else and share that as part 6. You actually have to do it. Do what you've learned from someone else, practice it, and then attach it to your work. That's it. Take care.